Welcome to Jeremy's IT Lab. This is a free complete course for the CCNA. If you like these videos, please subscribe to follow along with the series. Also, please like and leave a comment, and share the video to help spread this free series of videos. Thanks for your help. In this video, we will look at wireless network security, specifically exam topic 1.11d, encryption, and exam topic 5.9, describe wireless security protocols, WPA, WPA2, and WPA3. You've probably noticed by now that there are a lot of new concepts that you need to learn to understand wireless networks. Wireless security is no exception, and this video will be an overview of a lot of new concepts. So take notes and do extra research if you have to, but make sure you have a basic understanding of the concepts introduced in this video before you take the CCNA exam. Here's what we'll cover. First, I'll give a brief introduction to wireless network security and summarize what we'll cover later in the video. Then I'll introduce various authentication methods, ranging from not-so-secure methods to the most secure methods used in modern networks. Then I'll introduce various encryption and integrity methods. Encryption plays a role in all kinds of networks, but it's especially important in wireless networks, because a signal can be received by anyone within range of the sender, not just the intended recipient. And integrity means making sure that messages aren't modified by any attackers while in transit. Finally, we'll look at Wi-Fi Protected Access, WPA, which was developed by the Wi-Fi Alliance to provide standard sets of wireless network security protocols. Watch until the end of the video for a bonus practice question from Boson Software's XSIM for CCNA, the best practice exams for the CCNA. As you know, security is important in all networks. However, it's even more essential in wireless networks. The main reason for that is, because wireless signals are not contained within a wire, any device within range of the signal can receive the traffic. In wired networks, traffic is often only encrypted when sent over an untrusted network such as the internet. You usually don't encrypt wired traffic within the LAN, for example. But in wireless networks, it is very important to encrypt traffic sent between the wireless clients and the AP. That's because, as I said before, any device within range of the signal can receive the traffic, but we want to ensure that only the intended recipient or recipients can read it. So in this video, we will cover three main concepts: authentication, encryption, and integrity. You've heard these terms before, but let's look at them from a wireless perspective. We'll look at these in more depth later in the video, but first here's a quick overview of each. First, authentication. As mentioned in the previous video, all clients must be authenticated before they can associate with an AP. Authentication just means verifying the identity of a user and/or device. In a corporate setting, only trusted users and devices should be given access to the network. However, a separate SSID, which doesn't have access to the corporate network, can also be provided for guest users. Those guest SSIDs have less strict authentication requirements, and probably only give access to the internet, not to internal company resources. Not only should the AP authenticate the identity of clients, ideally, the clients should also authenticate the AP to avoid associating with a malicious AP. A malicious AP could trick users into associating with it, and then it can carry out attacks such as a man-in-the-middle attack. There are multiple ways that authentication can be carried out, for example with a password, a username and password combination, or with digital certificates installed on the devices. For review, remember that before associating with an AP, the client must first go through an authentication process like this. Okay, we'll look at authentication in more detail soon, but let's introduce the next concept. Next is encryption. Traffic sent between clients and APs, so any wireless traffic, should be encrypted so that it can't be read by anyone except the AP and the client. You should know this already, but encryption means scrambling up the message so that only the sender and the intended recipient can read it. There are many possible protocols that can be used to encrypt traffic. It's important that the sender and recipient use the same protocol, or else it would be like they are speaking different languages. The recipient wouldn't be able to decrypt the sender's messages. Note that all devices on the wireless LAN will use the same encryption protocol. However, each client will use a unique encryption and decryption key so that other devices can't read its traffic. Only the AP will have the appropriate key to decrypt the client's traffic. The other clients won't be able to decrypt it because they are using different keys. However, there is also a group key, which is used by the AP to encrypt traffic it wants to send to all of its clients. All of those clients keep a copy of that group key, so they can decrypt the traffic. Again, we'll look at wireless encryption methods in greater detail soon. But before that, let's introduce the final concept, integrity. As explained in the Security Fundamentals video of the course, integrity ensures that a message is not modified by a third party. It is not modified in transit. So the message that is sent by the source host should be the same as the message that is received by the destination host. To ensure that, a MIC, Message Integrity Check, is added to messages to help protect their integrity. To demonstrate how it works, let's say the PC on the left is a client of the AP on the right. First, the sender calculates a MIC for the message and attaches it to the message. Just like encryption, there are many different protocols that can be used to calculate this MIC, and it's important that the sender and receiver use the same protocol. Then the sender encrypts the message and MIC, and sends the frame. The recipient decrypts the message, and then independently calculates a MIC for the message, using the same protocol as the sender. It compares the two MICs, and if the MIC calculated by the sender and the MIC calculated by the recipient are the same, the recipient assumes the message wasn't tampered with. Note that if the two MICs aren't the same, if they are different, the message will be discarded. So instead of saying a MIC helps to protect the integrity of messages, it could be more accurate to say that it helps to identify if the integrity of a message has been compromised or not. If the integrity has been compromised, the message will be discarded. Now let's move on to look at various wireless authentication methods. This will just be an overview of various authentication methods. We won't be going in depth. However, we will be covering a lot of them. Here they are, 7 different methods. The good news is you don't need to know any of them in depth. Just a basic understanding of each is fine. But make sure you take notes. Even though you only need a basic understanding, it can be easy to mix up these different authentication methods when first learning them. The original 802.11 standard included 2 options for authentication. The first one is open authentication, which is very simple. The client sends an authentication request, and the AP accepts it. No questions asked, no credentials required. So this is clearly not a secure authentication method. The AP just accepts all authentication requests. However, it is still used today in combination with other authentication methods. After the client is authenticated and associated with the AP, it's possible to require the user to authenticate via other methods before access to the network is granted. Think about Starbucks Wi-Fi or other public Wi-Fi. You might be free to associate your device with the AP without even entering a password, but then you are probably required to log in via a web page or something like that to authenticate. After that authentication, your device is granted access to the internet. So, open authentication itself is not secure at all, but it can be combined with other methods. Then, the second method in the 802.11 standard is WEP, Wired Equivalent Privacy. Actually, WEP is not just an authentication method, it provides encryption too. For encryption, it uses the RC4 algorithm. If you're curious about RC4, try reading on Wikipedia, but for the CCNA, I recommend just knowing its name. WEP is a shared key protocol. It requires the sender and receiver to have the same key, a shared key. Those WEP keys can be 40 bits or 104 bits in length. However, those above keys are combined with a 24-bit initialization vector to bring the total length to 64 bits or 128 bits. Again, read up on Wikipedia if you're curious about the purpose of an initialization vector, but you don't have to know it for the CCNA. Now, usually longer key lengths are more secure, but WEP is not secure and can be easily cracked, regardless of the key length. You definitely should not use WEP on modern wireless networks. So that's WEP encryption. But how can WEP be used to authenticate a device? Here's how it goes. First, the AP sends a challenge phrase. This is just a series of bits. The actual contents don't matter. The client then encrypts the challenge phrase using the WEP key and sends it back. Finally, the AP takes the client's encrypted challenge phrase and compares it to the AP's own encrypted challenge phrase. If they match, it means the AP and client use the same key to encrypt the phrase, so the authentication is successful. Basically, the AP is just testing if the client knows the shared key or not. Note that WEP can be used just to provide encryption, or to provide both encryption and authentication. If WEP authentication is not used, Open authentication will be used, and WEP will only be used for encryption. Okay, I just covered the first two options for authentication, Open and WEP. However, Open authentication on its own is not secure, and WEP is definitely not secure either as an encryption method or an authentication method. So, new wireless authentication methods were needed. Now let's look at those more secure methods, the different variations of EAP, Extensible Authentication Protocol. EAP itself isn't a single authentication protocol, but rather a framework which many other protocols, called EAP methods, are based on, such as LEAP, EAP Fast, etc. So what is EAP? It is an authentication framework. It defines a standard set of authentication functions that are used by the various EAP methods. We will look at 4 of those methods: LEAP, EAP Fast, PEAP, and EAP TLS. Note that EAP is integrated with a protocol called 802.1x, which provides port-based network access control. Let me explain. 802.1x is used to limit network access for clients connected to a LAN or wireless LAN until they authenticate. Here are some specifics. There are 3 main entities in 802.1x. First, the supplicant. This is the device that wants to connect to the network. Then there is the authenticator. This is the device that provides access to the network. Finally, the authentication server. This is the device that receives client credentials and permits or denies access. 802.1x is used in all kinds of networks, both wired and wireless, so you definitely should know these 3 definitions: supplicant, authenticator, and authentication server. In an 802.11 wireless LAN, the supplicant is the client that wants to connect to the network, for example, a laptop. The authenticator is the device that provides access to the network, the access point. But actually, in a split MAC architecture, it's the wireless LAN controller that manages the authentication, not the AP itself. And the authentication server is usually a radius server. So here's how it works. The 802.11 wireless authentication required to associate with the AP is simply open authentication. Now the client is associated. However, it does not yet have full access to the network. The only traffic allowed from the client is traffic required for EAP authentication. And it is the authentication server that will check the client's credentials and decide to permit access or deny access to the network. So the WLC is now a middleman in the authentication process. The 802.11 authentication required to simply associate with the AP is open, but then there is the additional step of EAP authentication that is required to get access to the network. So let's look at some different EAP authentication methods used in wireless LANs. The first is LEAP, Lightweight EAP. It was developed by Cisco as an improvement over WEP. Here's how it works. Clients must provide a username and password to authenticate. But in addition to that, mutual authentication is provided by both the client and server sending a challenge phrase to each other. In WEP, only the server sent a challenge phrase, but in LEAP, both client and server send challenge phrases. So first challenge phrases are exchanged. Then, each device encrypts the other's challenge phrase and sends it back, and they use that to authenticate each other like in WEP. To further improve the security, dynamic WEP keys are used. These are WEP keys that automatically change over time to make it harder to crack the encryption. However, like WEP, LEAP is considered vulnerable and should not be used anymore. Instead, you should use one of the next methods. The next method is EAP Fast. EAP Flexible Authentication via Secure Tunneling. This was also developed by Cisco. It consists of 3 phases. First, a PAC, Protected Access Credential, is generated and passed from the server to the client, like this. This PAC is like a shared key and is used in the next phase to establish a secure TLS tunnel between the client and authentication server. So now there is a secure tunnel established that can be used for secure encrypted communications. The final step is that the client is authenticated within the TLS tunnel. Okay, that's EAP Fast. The last 2 methods are similar to EAP Fast, but different in some key ways. Next is PEAP, Protected EAP. Like EAP Fast, it involves establishing a secure TLS tunnel between the client and server. But instead of a PAC, the server has a digital certificate. It will show its digital certificate to the client, and the client uses this to authenticate the server. This certificate is also used to establish the secure TLS tunnel. And because only the server provides a certificate for authentication, the client must still be authenticated within the secure tunnel. One protocol that can be used for that authentication is called MSCHAP, Microsoft Challenge Handshake Authentication Protocol. So that's PEAP. Remember that EAP Fast uses a PAC, but PEAP uses a digital certificate. However, both involve establishing a secure tunnel and then authenticating the client inside of that tunnel. And finally, the last authentication method is EAP TLS, EAP Transport Layer Security. Whereas PAP only requires the AS, authentication server, to have a certificate, EAP TLS requires a certificate on the AS and on every single client. It is considered the most secure authentication method, but it is more difficult to implement than PEAP, because every client device needs a certificate. That can add a lot of complexity, time, and effort. Because the client and server authenticate each other with digital certificates, there is no need to authenticate the client within the TLS tunnel. However, the TLS tunnel is still used to exchange encryption key information, and we will be talking about different encryption methods next. To summarize, EAP TLS is the most secure authentication method, but it takes more effort to implement, so many enterprises might prefer PEAP instead. So those are the authentication methods you should be aware of for the CCNA. To really understand these protocols, you will need a lot more information than I gave you in this section. But the goal of this video is just to give an overview, not to get deep into the details. And remember, authentication refers to verifying the identity of a device or user. Although I did mention encryption throughout this section, in the next section we will talk about specific encryption methods used to keep data private and secure. So these are the encryption methods, in addition to integrity methods we will discuss: TKIP, CCMP, and GCMP. We could include WEP in this list too, but I already mentioned it in the previous section. As I said before, encryption of wireless traffic is absolutely essential, so make sure you have a basic understanding of these encryption methods. First up, TKIP, Temporal Key Integrity Protocol. As I said before, WEP was found to be vulnerable. However, wireless hardware at the time was developed to use WEP. So a temporary solution based on WEP was needed until a new standard was created and new hardware was built. That temporary solution was TKIP. It's based on WEP, but adds various security features. Now, I'm going to give you a list here, but I don't think you need to memorize it. Just understand that TKIP is like a more secure version of WEP. So, TKIP uses a MIC to protect the integrity of messages. Hopefully you remember what a MIC is from earlier in the video. Also, a key mixing algorithm is used to create a unique WEP key for every frame, instead of each frame using the same key. This makes it harder to crack the encryption. The initialization vector, which I mentioned earlier, is doubled from 24 bits to 48 bits, which makes brute force attacks to crack the encryption much more difficult. The MIC includes the sender MAC address, used to prove the identity of the frame sender. Also, a timestamp is added, so attackers can't do a replay attack. Replay attacks involve resending frames that have already been sent. Check Wikipedia if you want to get an overview of replay attacks. Similarly, a TKIP sequence number keeps track of frames sent from a source MAC address. This also protects against replay attacks, because a frame will be dropped if the sequence counter is incorrect. As I said, you probably don't have to memorize all of the above features. Just know that TKIP was developed as a more secure temporary solution after WEP was found to be vulnerable. And know that TKIP is used in WPA, Wi-Fi Protected Access version 1, which will be discussed in the next section. Next up is CCMP, Counter CBC MAC Protocol. It was developed after TKIP and is more secure. It is used in WPA2, and again, I will explain WPA in the next section. Note that for a device to use CCMP, it must be supported by the device's hardware. Old hardware built only to use WEP or TKIP cannot use CCMP. It consists of two different algorithms to provide encryption and a message integrity check. For encryption, it uses AES counter mode. AES is the most secure encryption protocol currently available, and is used all over the world by corporations, governments, etc. There are multiple modes of operation for AES, and CCMP uses what's called counter mode, because it offers high performance, high speed. Then it uses CBC MAC, Cipher Block Chaining Message Authentication Code, as a message integrity check to ensure the integrity of messages. You don't have to know exactly how CBC MAC works, just know that it's a kind of MIC. So that's how CCMP provides encryption and integrity. Finally, there is GCMP, Galois Counter Mode Protocol. It is more secure and more efficient than CCMP, and its efficiency allows higher data throughput than CCMP. It is used in Wi-Fi Protected Access 3. Like CCMP, it consists of two algorithms. First, AES counter mode encryption, and then GMAC, Galois Message Authentication Code, which is used as a MIC to ensure the integrity of messages. Again, don't worry about exactly how GMAC works, just know that it's a kind of MIC. So, those are the encryption methods you need to know. Again, remember that I also introduced WEP earlier, and it is used for encryption also. I've added some basic notes about each protocol below. So far, we've covered a lot of different authentication and encryption methods. Make sure you have taken notes on each and know their similarities and differences. Now, with so many different authentication, encryption, and integrity methods, which ones should we choose? Which combinations work together and which don't? And how can we know which hardware supports which standards? To simplify things and create standard sets of protocols to be used, the Wi-Fi Alliance developed the WPA, Wi-Fi Protected Access, industry certifications. Let's look at WPA now. The Wi-Fi Alliance has developed 3 WPA certifications for wireless devices: WPA, WPA2, and WPA3. Note that the first one is just called WPA, not WPA1. For a device to be WPA certified, it must be tested in authorized testing labs. This is just like how the Wi-Fi Alliance certifies devices for Wi-Fi 4, Wi-Fi 5, Wi-Fi 6, etc. They also certify devices for WPA, WPA2, and WPA3 security. All 3 of the WPAs support 2 different authentication modes. First is personal mode, in which a pre-shared key, PSK, is used for authentication. For example, when you connect to a home Wi-Fi network, enter the password, and are authenticated, that is personal mode. It's common in small networks, such as SOHO networks. Note that for security purposes, the PSK itself isn't actually sent over the air. A 4-way handshake is used for the authentication, and the PSK is used to generate encryption keys. If the devices use the same PSK to generate encryption keys, they will be able to decrypt each other's traffic, meaning that they will know that the other device is using the same PSK. In addition to personal mode, there is enterprise mode. This is the mode that uses 802.1x with an authentication server. I introduced a few EAP methods, and they are used with enterprise mode, although WPA doesn't specify any specific method. So, all EAP methods are supported, such as PEAP or EAP-TLS. Now let's look at WPA, WPA2, and WPA3. The first WPA certification was developed after WEP was proven to be vulnerable, and it includes the following protocols. TKIP, which as you know is based on WEP, provides encryption and integrity. Authentication can be provided by 802.1x and EAP when using enterprise mode, or by PSK when using personal mode. But WPA didn't last very long. After more secure protocols and hardware were developed, WPA2 was released, and it includes the following protocols. CCMP is used to provide encryption and MIC. And again, authentication can be done via 802.1x using EAP or PSK. And finally, in 2018, WPA3 was released. It uses GCMP for encryption and integrity, and once again supports 802.1 based or PSK based authentication. In addition to that, it offers several additional security features. Here are a few examples. There is a feature called PMF, Protected Management Frames. It protects 802.11 management frames from eavesdropping and forging. Actually, this was available as an optional feature in WPA2, but WPA3 makes it mandatory. Also, SAE, Simultaneous Authentication of Equals. It protects the four-way handshake when using personal mode authentication. The last example I'll give is forward secrecy. It prevents data from being decrypted after it has been transmitted over the air. This protects against attacks in which an attacker captures wireless frames and then tries to decrypt them later to read the contents. Okay, that's all I'll say about the WPA certifications. Basically, they take the various security protocols I mentioned in this video and package those protocols into standard sets. Hardware is then tested and certified to make sure it supports these standards. Okay, here's what we covered in this video. I'd say the content of this video was quite wide but shallow. You got a general overview of a lot of different security features. Make sure you know the difference between PEAP and EAP TLS, or CCMP and GCMP, for example. Also know which protocols are included in WPA, WPA2, and WPA3. And make sure to watch until the end of the quiz for a bonus practice question from Boson Software's XSIM for CCNA, the best practice exams for the CCNA. Now let's go to quiz question 1. What does GMAC provide to a secure wireless connection? Pause the video now to select the best answer. Okay, the best answer is B, MIC, Message Integrity Check. GMAC is used as part of the GCMP protocol to verify message integrity as a message integrity check. GCMP is part of the WPA3 certification. Okay, let's go to quiz question 2. Which of the following are part of the 802.1x authentication architecture? Select 3. Okay, pause the video now to select the best answers. The answers are A, supplicant, D, authenticator, and E, authentication server. These are the three entities involved in 802.1x authentication. In an 802.11 wireless network, the wireless client is the supplicant, the AP or WLC is the authenticator, and a server such as a Radius server acts as the authentication server. Okay, let's go to question 3. Which of the following encryption and integrity methods is considered most secure? Pause the video now to select the best answer. Okay, the answer is C, GCMP. These protocols were developed in the order WEP, TKIP, CCMP, and then GCMP, and GCMP is the most secure. If your hardware supports it, it is recommended to use GCMP whenever possible. Okay, let's go to question 4. Which of the following AES methods requires a certificate on both the supplicant and the AS? Pause the video now to select the best answer. Okay, the answer is D, EAP TLS. Both PEAP and EAP TLS involve digital certificates for authentication, but PEAP only requires that the AS has a certificate. EAP TLS, on the other hand, uses certificates to authenticate both the supplicant and the AS, so they both need a certificate. Okay, let's go to question 5. Which of the following WPA3 security features protects the 4-way handshake when using personal mode authentication? Pause the video now to select the best answer. Okay, the answer is A, SAE. SAE is simultaneous authentication of equals, and it allows for a more secure 4-way handshake during authentication using personal mode. Okay, that's all for the quiz. Now let's try a bonus question from Boson Software's XSIM for CCNA, the best practice exams for the CCNA. Okay, here's today's Boson XSIM practice question. Which of the following is used by WEP to provide encryption? Select the best answer. Okay, there are 5 choices, so please pause the video now to select the best answer. Okay, let's check. So, WEP is an old form of encryption as well as authentication used in wireless networks, and it is no longer secure. So what did it use to provide encryption? Definitely not GCMP, CCMP, AES. These are newer and much more secure. How about TKIP? Well, TKIP was based on WEP, and it was more secure than WEP, but it still is not considered secure. So it is not accurate to say that WEP used TKIP to provide encryption. The more accurate statement is that WEP used RC4 to provide encryption. This is the encryption algorithm used by WEP. And as I said many times before, it is not secure, so you should not use it in modern wireless networks. Okay, I'll click on Show Answer, and there it is. RC4 is correct. So here is Boson's explanation. I recommend pausing the video now to read it. Okay, and here are Boson's references. First, to their own CCNA curriculum on security fundamentals, wireless security, as well as a reference to the CCNA official cert guide covering securing wireless networks. Okay, so that was a quick look at Boson Software's XSIM for CCNA. These are without a doubt the best practice exams for the CCNA, and I highly recommend them. If you want to get Boson XSIM, please follow the link in the video description. There are supplementary materials for this video. There is a flashcard deck to use with the software Anki. There won't be a lab for this video. Again, we didn't cover any configurations in this video. However, the next video of the course will be dedicated to wireless LAN configuration, and we will have a practice lab after that video. Before finishing today's video, I want to thank my JCNP level channel members. To join, please click the Join button under the video. Thank you to Valerie, Marco, Tanvir, Apogee, Vitaus, Benji, Kwa, Ricardo, Safet, Mazin, Mir, Petrocius, Dragos, Gerard, Tom, Martin, Tebogo, Pavel, Abraham, Sergey, Njoku, Suki, Kenneth, Seamus, Marcel, Coney, Echo, Gustavo, Prakash, Nasir, Erlison, Ed, John, Funny Dart, Velvet Jacob, Boson Software, Devin, Jonathan, and Vance. Sorry if I pronounced your name incorrectly, but thank you so much for your support. This is the list of JCNP level members at the time of recording, by the way, October 3rd, 2021. If you signed up recently and your name isn't on here, don't worry, you'll be in future videos. Thank you for watching. Please subscribe to the channel, like the video, leave a comment, and share the video with anyone else studying for the CCNA. If you want to leave a tip, check the links in the description. I'm also a Brave verified publisher and accept BAT or Basic Attention Token tips via the Brave browser. That's all for now.